Welcome all back to this last part of the section of today's lecture. Thank you very much, Christina, and the space is yours.
Okay, thank you, Esteban. Yes, we are here for the last part of the tutorial today that I hope all of you are following well in time. So far we have been working with the data. We download a catalog, we read the columns of the catalog, and we split the sample to build two different catalogs of galaxies, one for massive galaxies and one for low mass galaxies. Then the last points of this tutorial, I'm going to share the screen here. Yes. The last points of these tutorials are here. Then now we should make the point number 7, which is to create a log-log plot showing the mass distribution for both catalogs that you created. Choosing, well, you can choose the fitting that you consider more convenient. And this is just the mass distribution, then is the number of sources as a function of the halo mass for both samples. And you have to make both axes logarithmic because, of course, we are working here with very high values of mass and with high values number of galaxies too. Then you can try to work on this. And also, I'm asking you to save the positions of the galaxies for both catalog in two separated files. And this is because in the tutorial tomorrow, we are gonna work with those catalogs to measure the clustering for both samples. Then I'm gonna give you 10 more minutes now for you to work on this part. And I'm gonna be back here to show you how to do this and how the plots should looks like. And if you have any question, let me know. I'm gonna be here in case you need it. Okay. Then I'm back now again. And I'm gonna show you how I will do the points 7 and 8 in the tutorial or in the workshop. Then first, I'm asking for you to make a log-log plot showing the mass distribution for both catalogs. Then I'm gonna share my screen. Okay, and here. Can you see my screen or not? Not sure.
Hi, Christina. Yes, we are seeing your screen. Now you have an increased font as well.
Yes.
Perfect. Thank you.
I figured out how to increase the size.
Thank you very much.
Is good this size now, or is still too small?
It's a bit better than before. If you could make it a little bit higher.
Cool. Maybe
I think it's now is completely fine. I think everybody can read this.
Okay, great.
Thank you.
No problem. Then I'm gonna plot here. I will try to write the code in real time because maybe it's easier for you to follow this, especially because you're not an ideal programmer. And as Esteban said, again, you don't have to try to follow the exact syntaxes that I'm following, because in Python you should know your own syntaxes for this. But I'm gonna just plot here the histograms. In this case, I wanna plot the halo mass for first the position of the low mass galaxies. And I have to define a binning, which is the width of each bin for the histogram. In this case, I choose this value because the masses for the low mass goes from like around 10 to the 11. Then I'm gonna try to make a smaller step, and then we can see better the results. And also here I can define logarithmic x-axis and logarithmic y-axis. And I'm gonna define also the range to show the histograms. Then I can do it like this. And just to visualize this better, that should work. And I can repeat the same for the second sample. Then this should be, the high mass sample. In this case, the masses are much higher. Then I can choose like a little bit larger bin here. And I overplot the result with a color red. Also thick trees, just to make the plot like more clear. Okay, so if I run this here, I'm gonna get my plot just here. Then this is the histogram. The black one is for the low mass sample, and the red one is for the high mass sample. This is the number of galaxies as a function of the halo mass. And as I mentioned before, the low mass sample is much more narrow, is in halo mass, because I by construction I did the samples like to have the similar number of sources. Then at low mass, we just need to trace a small range of halo mass to get the total number of sources that we need, around 10,000 in total. And for the high mass, I need to explore a much wider range to get this, because as you can see here, we have only some few halos with around 10 to the 13 solar masses, just around 20 or 30 halos with that mass. Then that is not very common because that is a very high mass, but low mass halos are much more common. Then we have much more galaxies with lower masses compared with higher masses. And the next step is just to save the positions of the galaxy for both catalog in separated fields. Then we can use those files tomorrow. And I can do this quickly here. I will call low.dat one of the catalog, and I'm going to print this is in elements of post-low. Yeah, post-low. Then I just print the coordinates and the position. Same for inclination. And also repeat for the high mass sample. Okay, then we should be done. Oops. Yeah. Okay. Then I should have the catalogs here. Then, for example, this is for the high mass catalog. It's just one file with 2 columns. This is the coordinates of each galaxy in the sample, and the low file looks similar to this one, right? Yes, and we only have 10 more minutes. Then I'm gonna give you just only 5 minutes to make the number 9. Is just to plot the positions, then that should be 5 minutes should be enough, and we can discuss a little bit how this looks like, which is what I'm asking in number 10. Then I'm gonna stop sharing now and be back here in 5 more minutes. Then you have time to create those final plots. Okay. We have only 4 minutes left. Then if you have not finished yet, you can finish together with me. Okay. So the final 2 points is to plot the sky distribution for both catalogs. Then I'm gonna just plot this here. This is just the coordinated low, the declination and ray ascension for one of the catalog. So here I'm just defining the what type of points I want to plot and the size. Okay, maybe I can add the title. Yes, and I'm gonna also plot the same for the other catalog. This is high. Title. This is low mass. This is high mass. Okay. Then I'm gonna run this code and should have the plots right here. Oops. Yes. Then this is how looks the sky distribution of the low mass galaxies. And then it's just the coordinated for the 10,000 galaxies. You can see that, as I said before, this is a simulation. Then it's just a square region in the sky. The coordinated goes from 0 to 1.4 degrees in both directions, in declination and ray ascension. And this is the plot for the high mass galaxies. Then it looks very similar. Then basically when I ask you here to compare the plots just by eye, you can not really tell me which of those samples are more clustered than the other, right? I mean, by eye, it's not clear. It's not strongly clear that one of those has a very different clustering than the other, or is more grouped or accumulated, or has a different structure or distribution than the other. Both of them looks pretty similar. Then what we are gonna make tomorrow is to measure the actual clustering, then using a mathematical description. I'm gonna stop sharing. Using the mathematical description to see if mathematically we still see that both samples has the same clustering or the same properties in terms of their distribution. Then tomorrow we're gonna to continue working on this. Then I'm gonna upload the code that they use, and also in case that you couldn't create the files with the subsample of galaxies that we're gonna use, I also will put those into my website. Then you can download it tomorrow in case you miss it, or also I will put the plots there. Then you can check what you should obtain. Yeah, and that is for now. Please let me know if you feel this was too slow or too fast, then we can try to do it better tomorrow. Any other suggestion also will be welcome. And I think that is everything for today.
Okay, thank you, Christina. Thank you very much for the lecture of today and for the workshop. It is very interesting. Remember, you all, that you can contact Christina on the email that is now displayed on the screen. If you have any questions, or if you want to reproduce what she did on IDL, you can do exactly the same using Python or any other programming language. She will upload everything on her webpage, and we'll be paying attention. If you need to go to her webpage and you don't have it right now, it will be in the comments that was passed in the previous videos. And I hope to see you all tomorrow at the same time, 8 in the morning in Colombian time, 2 in the afternoon EU time. Thank you again, Christina. Thank you all for participating.
Yeah, thank you.
Bye.